So this video will be looking at quadratic sequences, but before I go on with quadratic sequences, there is a thing that from the previous video I forgot to mention, and that's when we look at linear sequences, we often associate this with the general form that we use, which is y is equal to mx plus c. So if some of you are used to filling out a table where you've got, for example, x here and y here, and you're trying to find out the values, for example, 1, and you plug in the equation, that's exactly what we've done with the last video. We looked at n instead, and let's just say, for example, that happened to be u. So this could be interchangeable in the sense that this could be u is equal to mn plus c, where m is just the change that we looked at, that constant change, and plus c was the thing that we looked at where if there was a number here, how did we get to that number? If there was a number here, how did we get to that number? So if this doesn't make sense at this stage, it's probably best you do watch the linear video again. So the next thing we have to recognize is that when we have quadratics, we represent quadratics in this general form of ax squared plus bx plus c, or y equals, sorry. And so you can probably guess we're going to come up with another table where we have values for u and, for example, values for n. And we're asked to find these particular values, find the second differences or find first differences. And so this can often be substituted with, for example, u is equal to an squared plus bn plus c. So the reason why I've stated this particular equation is that we will be using it later on just to kind of understand where we get this a term from. So let's look at an example. So the first example that I've got here, the sequence is 4, 9, 16, 25, and 36. I don't know if this is a linear sequence. I don't know if this is whatever kind of sequence it is yet, because I just need to check the differences. So let's have a look at the differences between each of these numbers. The first one, the difference between 9 and 4 is 5. The difference between 16 and 9 is 7. The difference between 25 and 16 is 9. And the next one is 11. So we can actually say here that this sequence will not be linear, because we looked at the linear sequences and we said that if the number the successive numbers are going up by the same value, then yes, it's linear, but it's not in this case. So the next thing you need to consider is something that we call the second differences, or in other words, the differences of the differences. So what we need to do is we need to ask ourselves, what is now the difference between 7 and 5? The second difference will give us 2, and this one will give us 2, and this one here will give us 2. And surprise, surprise, we come up with a constant difference. But what does this actually mean in the context of our question? So the reason why this particular number here is important is one of two reasons. One, it tells us that it is a quadratic because the second difference is constant. Okay, if the second difference is constant, it is a quadratic sequence. The next thing we need to consider is this form that we looked at before, which was the form an squared plus bn plus c. So the reason why this 2 is important is because to work out what value a is, to work out what the value of b, to work out what c value is, we need to go through this whole step. But this first step is working out the value of a. So what we actually need to do is just take half of whatever this value is. Or in other words, the value of a is equal to half of the second difference. Or what's half of the second difference in this case? It's half of 2 is 1. So in other words, a is equal to 1. Or in other words, if I look at this particular equation that I will have, my equation will start off with n squared. So now I'm going to plug that into here, n squared. Now, what I'm going to do is I'm actually going to calculate what is my n squared sequence going to be. So my n squared sequence will be 1, 4, 9, 16, and 25. How did I get that? I just looked at this number here and I squared it. Now the next question is, what is the sequence minus the above row? So the sequence minus the above row. So 4 take away 1 will give me plus 3. 9 take away 4 will give me plus 5. 16 take away 9 will give me 7. And you can probably guess what the next one is going to be, and this one will be plus 11. So that's kind of interesting because we still get this thing that's going on. So we know one part of our puzzle is definitely going to be n squared. But the next thing we actually have to do is work out what the next pieces are. So what is the value of b and what is the value of c? And this is why this thing here is crucial. So let's keep going on here. Now, we're actually going to treat this as a linear sequence. So this particular sequence right here, we're going to find the rule of this sequence, and we're going to see what's going on. So what's the difference between 3 and 5? Plus 2. Difference between 7 and 5, plus 2, and plus 2. So that's kind of interesting in that sense, because now it actually turns into linear. This second part is a linear sequence. And if you remember from the last video, we looked at this is the fact, also not the fact, this is the number, or this is what we express as 2n. So now let's look at our 2n sequence. So 2 times 1 will give me 2. 2 times 2 will give me 4, 6, 8, and then 10. So now I need to just find the differences once again. And so what's the difference between 2 and 3, or 3 and 2? It's plus 1. The difference between 5 and 4, plus 1. Difference between this and this, plus 1, plus 1, plus 1. And let's tie this off with a different color. You can see from here we've actually inherently come up with all the values that we want, because the first thing that we came up with was the n squared, which was that. The next thing that we needed to calculate was that b, which happened to be this thing, 2n. And the last thing we just need to tack on is this final difference that we have, which happens to be plus 1 and plus 1. And so you can see this is the rule that we end up with using this whole process. So we will go through another example in another video. However, that should tie off this. Now, like all good habits, we should check. Let's check, for example, n equals 2. If this is the right formula, n equals 2 should give us 9. So check. N equals 2. So let's check 2 squared plus 2 times 2 plus 1 will give us 4 plus 4 plus 1, or in other words 9. Therefore, this is correct.